and welcome to our next session on if statements. Last time we've talked about dictionaries and tuples. We've talked about a variety of different data containers, lists, sets, just variables. And we're going to talk about if statements today, but first we're going to start off with a couple of other smaller data containers that are extremely important, and we'll talk about those here in just a moment. So today we have two new ones. We have none and Boolean. So none is going to be exactly what it sounds like. It is none. It means that there are no values in the data set or in the data container. We'll talk about why this is important here in a moment. And then we have Boolean values, true or false. Okay, this is going to be critical when we start to talk about data control structures in our data set. So none, sometimes referred to as null. Okay, none is a data type in itself, right? We use it to check if a variable has the value of none. Okay, we can do that in two different ways. We can say x is none, or we can say x has the value of none as indicated with two equal signs. Okay, so getting philosophical, only none can be none, right? The x is equal to 0 would still have the value of 0. Okay, a is equal to none is correct. A with an empty dictionary is not a null or none type value. It is simply an empty dictionary. Okay, so there are differences, and this is going to be important when we get to the control structures that we're going to be talking about. We also have Boolean type. Okay, this is true or false. Okay, hopefully, if you say if x is greater than y, or if is 5 greater than 3, that's true. Okay, is x less than 5, or is 5 less than 3? That's false. Okay, these are going to be important because they're going to help us shape how our control structures within Python allow us to manipulate and build different loops, iterations, and other things to guide our code the way that we want it to. So just for reference, empty data containers, empty strings, the integer 0, float 0, 0, none are all types of false. Okay, just for reference, it might be something that is useful later on as you're building a control structure. So let's talk about control structures. We'll talk about is operator first. So key thing to remember is that Python is object-oriented programming, right? Everything in Python are objects. Okay, and we can use the ID function to identify an object, right? An is operator compares the identity of two objects, and the double equal sign sees if the value is the same. Okay, so these are two different things. The same identity or of two objects might be very different than the values of two objects, or vice versa. Let's give you an example. So we have we call this list 1 is equal to 0, 1, 2. And then we have list 2 is equal to 0, 1, and 2. Right? These two have the same value. All right, we can say list 1 is equal to list 2. And it will tell us after it's connected to the server that this is true. Okay. However, if we look at the ID number of each of these objects, not the value, the ID of the object, you'll see that these are different, right? Small difference, right? But they are different things. So we can say print is list 2. Or rather, sorry, list 1 is list 2, and it's going to tell us false. Why are these two things different? They have the same value, right? The same thing. It's a list that contains 0, 1, and 2. They have the exact same value, the exact same thing, but they are different objects. Okay, list 1 is one object, list 2 is a second object. They have different values. So this is going to be important later on as we start to check whether or not things that come out of our statements are the same or allow us to put in additional controls into the data that allows us to do certain things if objects are equal or if they have the same value. Again, it's different. Okay, so another useful tool I just mentioned right now, using the percentage sign allows us to get the remainder of two numbers. So if we divide, say, 105 divided by 60 minutes in an hour, we'd have 45 minutes left. Okay, again, another useful tool. We're kind of wrapping up the useful tools before we get into the control structures. Okay, types of control structures. We have sequence, selection, iteration, or looping, and then branching or jumping statements. And these are what determine the structure and the flow of our code as it progresses. Okay. So what is sequence? Sequence is the default. Okay. The instructions occur one right after another. It is how things are going to happen within the code. What I demonstrated earlier. Here is an example, right? Sequence. This line happened, then this line happened, then this line happened, this line happened, then this line, and so on and so forth. Okay. So that is the sequencing of how this is the default. Okay. Here's another example. Instructions are executed one after another. Here what I'm doing is I'm defining a program or tool to add two numbers. I've defined it as the name sum of two numbers, or 2 and O. And then anything that I'm putting into this particular program goes indented underneath. And once that is done, I can call that program later on by using the sum of two numbers later on. One of the things to note is that this is sequential. So this thing will run, and it's going to run this line, and then this line, and then this line, and then this line. Okay, it's not going to do anything besides run those in order. Okay. A selection statement causes the program to be transferred to a specific flow based on whether or not certain conditions are met. Okay, so this is when we get into ways of iterating or ways of moving around our code that allow us to insert very cool and interesting and fun and useful things to allow us to do certain things. So what are some of the controls in this type of situation? We have if statements. We have a range function, which we'll get to next week. For loops, while loops, and then continue break pass statements. The last one we'll definitely get to a later class. For and while loops we might touch upon quickly today. Okay, so let's talk about the if statement. Right, the if statement is going to check whether or not a line of code is true, and if that code is true, it will stop. It will execute what it is given, and it'll be done. If it is false, it will ignore that code and move on to the following statement and check that. So let's see a kind of a better way of looking at this. So we have an if statement. So an if statement is building conditions into our code, right? So we have an if statement that says if one condition is met, do something. And then we can use what's called elif. E-L-I-F, it should be lowercase, we'll see that in a second. But if elif is met, do that second condition. Or if that condition is met, do something else. And if that doesn't work, if that's false, move to the next one. And if all of those are false, you can do what's the else one there at the bottom. Okay, so this is a way of saying, you can see it on the flowchart. If it is yes, do it. If not, move on to the next thing. Okay. So each condition is a Boolean expression. Okay, we are looking to get true or false out of these. Okay, and the structure of how we put these in and layer these matters, right? Because as soon as you get a true, it stops. Okay, it executes what it's supposed to do. Okay, so we can have as many elif clauses or sub-ifs as we want, including none. We can build in a ton. When we can have an else clause at the end or not, right? If we don't have the else clause, it just stops, and if none of your conditions are true, nothing happens. Okay, so an else clause makes it so that at the end, if nothing is true, there will be some sort of action that happens. Okay, so the way that these work is that, well, let's actually see it in action. Seeing it in action might be helpful. Let's say, for instance, that I am interested in applying a letter grade to a person's thing, and they received an 85. And I can say, and I'm interested in saying, okay, well, that 85 is a B. Okay, so we can say if grade is greater or equal to 90, and we put a colon, and then after that we can say print, let's say something fun. You received an A. Okay, and then I hit the backspace to go back to the front, and then say if grade is greater than or equal to 80, print you received a B, and we will just do a period because not as exciting as that, as an A. We'll do elif, and we'll do grade, and if you get above a 70, you received print you received a C. And then we'll do else, print better luck next time. Okay, and if we run this, we get you received a B. Okay, so and that's right, 85 is greater than 80, and so it falls into this. So what's happening here is every time a condition is set, right? Every time a condition is set, it will check if it is true or false, and if it is false, it will move to the next condition linked to the first one. So this elif links to this if. This else links to this if. Okay? And so we want to use these to kind of keep these all together. So this allows us to kind of, order and kind of go through and make sure that all of these things are bucketed correctly, and that kind of we can build out structure to our data. We have to be careful about how we order these things. So if I said greater than or equal to 70 is a C, greater than or equal to 80, 90 is an A. What is this going to give me? Am I going to get the right score? No, I'm going to get a C. Okay, so I've ordered it just conversely. I've just ordered it from low to high. But the important thing here is that because the condition was first met on the first line, with the first if grade is greater than 70, 85, that is true, it stops and runs that code. Okay, so it's not going to continue moving on after you've put in, once you've met the condition, it's going to stop. Okay. And so we can build in other things into this. We can build in, say, ranges if we wanted to. I like doing it this way, but if you wanted to build a range in here, so between 100 and 90, it would be an A, you could do that. It's not the A, you would not use an and, you would just kind of put it in. So let me give you an example here. So the way that we would do that is that we would put our first parameter here. So if it is 100 or less, and then greater than 90, you received an A. If less than 90 and greater than 80, you received a B. And that if it is less than 80 and greater than 70, you received a C. So you received an A. So it's in this threshold. So we build in ranges by putting the first parameter first, the data container, and this. So it's checking whether or not this falls between these two. Okay, so let's actually talk about, for a moment, other things that we can build in here. We can build in other fun things like multiple variables. So is sunny is equal to true, We'll say temperature is equal to, we'll say 75. And then let's build an if statement so that if we want to meet multiple conditions for our thing to do that, we can. So we can say if is sunny and temperature is greater than, say, oh, I don't know, 70. Well, I like it warm at the beach. We'll say 72. Yeah, 73. Yeah, there we go. 72. Print perfect weather, and we'll say elif is sunny or temperature is greater than I don't know, say 70. Go outside. Look for beach, and if you're going to go to the beach, you need it warmer. We'll do 80. And then we'll say else print out read a book inside. Okay, and so what we're doing here is we're saying, okay, if this variable is true and the temperature is greater than 80, print this. If is sunny is true or the temperature is above 70, do this. And if not, go outside and read a book. So we go outside because it's true and 75. If I take this to false, we have go outside. Why do we have go outside instead of stay inside? Well, because we use an or here, right? So this can be false, but the temperature condition is met. And because the temperature condition is met, we are printing out go outside. Okay, if I change this to and, what are we going to have? We're going to have read a book inside, because both conditions have to be met on this. We can also use not. Now, not in this case. We have to change that. So let's stick with or. I like or. Okay, so we have or go outside. Okay, we can't build in not with that one in that case because it was multiple. Anyway, okay, so we can build in multiple things. We can ask for inputs if we want, so that we can make this interactive. We can say, age is equal to an integer of an input, and we could say enter age, and then we could say if age is greater than 18. Say print, or less than 18, print you can't vote in the US yet, and else print you can vote in the US. So it'll prompt us to add an age, and we can put an age and say we are 35, and we can vote in the US. Okay, and every time we run it, we'll get the prompt again for this. So let's say 16, you can vote in the US. Okay, so these are if statements. They allow us to introduce control structures, allow us to build in different conditions, allow us to really shape how our code is providing different decisions, and allow us to do different things in the code to kind of really enhance our analytical capabilities. So that's it on if statements. I'll also post a kind of walkthrough on some other types of labs and whatnot so that you can see this in action. Okay, all right, see you next time.